Hello, everyone. First and foremost, we would like to thank you all for your presence today. Welcome to our final thesis presentation. Our topic is Deep Learning Based Waste Classification System for Efficient Waste Management. Here I am Shoptorshi Biswas. We have been researching under supervision of Dr. Mohammad Ghulam Rabiul Alam Sir, Associate Professor, Department of Computer Science and Engineering, BRAC University. Here are my teammates. In today's fast-paced world, waste is a big problem. Dealing with such a huge amount of waste requires integrated waste management. Statistics show that the world produced more than 2.02 billion tons of waste in 2016, and by 2050, this figure is expected to rise to 3.4 billion as Bangladesh is a developing country. Waste management becomes more challenging in developing countries. Bangladesh continues to use the traditional waste management system with manual labor as a priority. Most of the waste is landfilled and is not classified. Furthermore, standard waste management systems are incapable of efficiently managing such massive amounts of trash. Human beings need a clean and healthy environment to live well. The numerous procedures involved in solid waste management necessitate a significant amount of people and skill. We choose to employ deep learning based CNN approaches to create an automatic system for classifying garbage. The purpose of this study is to build up a CNN based model that can detect kitchen waste, glass waste, paper waste, metal waste, and plastic waste and apply them in the waste management system to classify this waste. Every research report demonstrates a separate set of garbage classification and detection strategies. This first paper proposes IoT-based smart bins as a solution to the traditional trash management system. This study used the TrustNet dataset and several deep learning models to categorize different types of garbage. This second research paper describes a smartphone app that can detect and correctly separate garbage pieces in a retagged image that has been clicked by the user. However, this model lacks a categorization of garbage. It can only recognize a chunk of garbage region, which is inconsistent with our goal of segregating waste into multiple categories. This research paper introduced a multi-tier hybrid deep learning system for autonomous sorting of garbage into multiple groups. However, this approach only divides photos into 3 groups. However, in our study, we will divide garbage into 5 categories based on its recyclability. Thanks for giving me this opportunity. Next.
Hello everyone, it's me Javed Hassan, ID 17201056. Dataset preparation. In order to train our model to classify wastes accurately, we need a dataset with a large number of images of different types of wastes. The challenge becomes harder when we do not have a standard dataset to follow in our project. So we decided to prepare our dataset from scratch. We have captured around 2000 images using the camera of our mobile phones, roaming around different areas of our hometown. But after that, we had to remove blurred, poor, and irrelevant pictures. Lastly, we have kept 1323 that we took from the real environment. From web scraping, we hand-picked around 553 best suitable images and included them in the dataset. While we were capturing the picture, we have tried to collect the most relevant pictures along with maximum subcategories. Well, during pre-processing, since we have captured images in mobile phones and stored the data with a high amount of pixels, that's why after renaming them with a unique ID, we have resized the image. Furthermore, we have compressed the image to keep the data file size as small as possible. Now we also annotate 5 main categories along with 48 subcategory. And there were 13 subcategory in plastic, 16 kitchen, 6, and so on. In total, subcategory was 48. During annotation, we added all subcategory in the annotation. We annotate the images using VZZ image annotator, which was in open source application. Well, we have total annotate 10,028 200 sorry 10,284 objects. The glass was 16%, metal 17%, kitchen 21%, paper 20%, plastic 26%. Thank you.
Hello everyone, this is Chinmay Majumdar, ID 182011108. Now I am going to explain the methodology part of our thesis. In our thesis, we have used a mass RCNN model. Mass RCNN is a deep learning model that not only classifies and localizes but also creates a segmentation marks around each detected object. This segmentation marks helps to determine the actual shape of the object, which is very handy feature. Mass RCNN is an extended version of faster RCNN with a mask for each detected object. Our mass RCNN model is based on ResNet network with 101 convolution layer and an advanced feature pyramid network. The ResNet FPN backbone achieves great accuracy and speed for feature extraction. ResNet uses deeper bottleneck structure, modifying the deep residual network block to reduce training time. It extracts features from an image through downsampling and passes the feature map to FPN. Feature pyramid network building block with a top-down architecture with lateral connection is used to build an in-network feature pyramid from a single scale input. While ResNet layer extracts feature by downsampling the image, the FPN tries to extract feature by upsampling. Then the feature map is proceeded to the region proposal network. Basically, in RPN, foreground and background classes are determined from an image. In the figure, we can see several anchor boxes of different sizes are generated. Intersection over union are found. When IOU is greater than equals to 0.5, it is considered as foreground class. When IOU is less than equals to 0.5, it is considered as background class. Then comes the ROI classifier, which has similar functionality like RPN. The ROI classifier network is deeper and tries to predict the class of the proposed region. The proposed region is ignored if it is classified as a background. This network also calculate refine the bounding box of the object in the ROI like the RPN. Then the foreground class is forwarded to the next level, which extract feature using ROI pool. While pulling the alignment of the extracted feature, an input can be compromised. So ROI align takes samples from different point of the feature map and apply bilinear interpolation to properly align the extracted feature with input. This increases the classification performance even more. Then it is forwarded to the segmentation marks. The mask creation phase is a very simple CNN that takes only the positive region selected by the ROI classifier to produce a marks for each instant detected in the image. The marks produced are flexible marks that contain floating point number in each pixel so that it can be upscaled to the original size of the detected object. Thank you.
Assalamu alaikum. Myself, Mohammad Naim Talukdar, ID 1720126. Now I am going to talk about GradCam. GradCam is a very effective explainable AI algorithm which can help to understand the decisions of any CNN-based model with distinguishable layers. GradCam generates class-specific heat maps from the input image on a trained CNN model. GradCam follows simple 3 steps to produce heat map in the activation center. At first, it computes the gradient of the class from the feature map generated at the last layer. The gradient calculated is 3D for a 2D image. Then the alphas are calculated by global average pooling over the height, width, dimension to get the weight for next step. Finally, we calculate the GradCam heat map by a weighted combination of forward activation maps followed by a redo. Then a simple upscaling algorithm is used to accurately fit the heat map on the original image. Here you can see the visualization of GradCam. Now it's time to talk about project setup. We set up our project on Google Colab Pro. The mask RCNN code was built on Python version 3.7, TensorFlow version 1.14, and Keras version 2.2.5. We have added GradeCam on the mask RCNN. We connected the last layer of FPN with the GradeCam. From that layer and its few following layers, the GradeCam gets its data to generate a heat map on the object. We have used 3 data augmentation techniques on our training set. These are scale, rotation, and flip. Now I am going to talk about training. We trained our mask RCNN model on the training set. While training, initially we have used COCO pre-trained weight. We have used only one GPU, and the image per GPU was set to 2. So our batch size is 2. Initially, we trained the head layers of the network for 20 epochs at different learning rates and at different RPN and MS thresholds. Then we trained all the layers of the network except the head layers for another 12 epochs with a stable learning rate at other parameters. At last, we trained all the layers of the network for 8 epochs with a stable learning rate and other parameters. We also tuned our parameters every 4 epochs to improve the accuracy depending on the result of the model after being tested. That's all from me. Thank you.
Assalamu alaikum. I'm Abdullah Nukib, ID 171011145. I'm going to explain the result analysis part. So as you can see that the training loss has been decreased to a very low, and after 40 epochs of training, and the validation loss also decreased very low. And you can see that the curves are not that much smooth because we have did some hyper tuning during the training session. So as you can see that some of the sample output from our test set, that our trained model is doing exceptionally well, and it's classifying each and every object from the image, and mask accuracy is also quite satisfying, and it's doing well even in the most complex situation. So with just watching this images, we can't evaluate our model. So we have so you can see the first see the accuracy of our model. As you know, our model is quite complex because there are some complex images of wastes. As you can see, we have plotted the accuracy here, and the accuracy is 92.58%. And now the accuracy is quite often misleading. So we have evaluated our model in other metrics as well. So you can see that the confusion matrix here, and we have calculated the precision and the recall here, and the red numbers are the true positive value from each category. So you can see that here the F1 score and also the classification error. You can see that the classification is error is very low, so which is also very satisfying. So you can see here that the F1 score is satisfying, as well as F1 score actually gives the balance between precision and recall. So you can see the overall performance here of our model here, which is quite good and satisfying. So now let's try to explain the results from mask RCNN using a GradeCam. As you can see in the first image from left, that the red zone area is the most important feature for this bottle. So you can see that this bottle, and in the second image, you can see that the same area, same area is the important for the bottle, the red zone area. And you can see the same thing in the third image as well, that this same kind of area is the most important feature for this bottle. But when we it comes to the we change the direction of the bottle, and we can see that the red zone shifted well and shifted, and you can see the same in the right image as well. So you can see that our model is graphs the features very well, and also trained very well, and quite fairly accurate. And you can also see that the our model is smartly actually smartly ignoring this sticker part, so which can be misleading, because this kind of This can be paper and other thing as well. So in conclusion, I want to say that our model is well trained, and from all evaluation metrics, it gives a very good result. And so I think if we implement this system in our waste management system, we can uh, hope to have a green and healthy life, and also a very good environment. So as you can see, this is the reference. So thank you so much. Assalam.